Hey guys, so today we're solving multi-step equations with variables on both sides. So today we're adding one additional step to what we've been doing throughout the last week. So our objective is you will learn to solve linear multi-step equations with variables on both sides, including special solutions. So our steps to solve, they have not changed yet, okay? So if you do the golden rule, if you've done it to one side, you have to do it to the other. We're still going to draw a line through our equal sign. We're still going to identify the variable. Step 3, we're going to simplify each side. So this was the new step yesterday. So we simplify each side by getting rid of the parentheses and by combining like terms. So those are the two new things from yesterday. Today, we're adding in one additional step. So today, we're going to be moving variables from one side to the other. But here's the big idea or the tip. You want to make sure that you move the smaller variable to the bigger side. So always move the smaller variable, okay? And we'll show you how to do that. And then step 5, we're going to use inverse operations to undo the math while we peel it back in layers, just like Shrek and the ogre. Remember, he said ogres are like onions. And so math problems are like onions. Okay, we have to peel it back in layers. Okay, let's talk about our special solutions. Special solutions are all real numbers. That's our first one we're going to talk about. And that is the symbol up there that you see on the top right of your screen. It looks like an R with, I say it's an R with 2 backs, but that is the symbol for it. So this occurs when we solve an equation and the final answer is a true statement. So for example, 2 equals 2 or x equals x. And what it means is that any number that you can imagine or think of and plug in for x will give us a true statement. And so how do we know when we have the solution all real numbers? Well, when the problem is solved, okay, both sides will be the exact same, no differences. So for example, I have 2x plus 3 equals 2x plus 3. When I subtract 2x, I get 3 equals 3. So that is a true statement. So we're good. The second special solution that we have is called no solution, and that is the symbol up there as well on the top right. No solution occurs when the final answer is a false statement. So for example, 3 equals -2, x equals -x. Those are not true statements. They're not the same. There is, and what that means is that there's no number that can make the equation true. It doesn't matter what number you can possibly think of, it will never work. So how do we know? Well, when the problem is in its simplest form, okay, the equation is not true. So for example, 2x plus 7 equals 2x plus 5. When I subtract the 2x, I get that 7 equals 5. That is not a true statement. Therefore, there is no solution. So let's do numbers 1 through 5 on the assignment today, and you'll have 6 through 10 to work on your own. I have 4x plus 12 equals 3x plus 7. So I come over here, draw a line through my equal sign, and identify my variables. My variables are on opposite sides of that red line. Okay, so therefore I can't just combine like terms. So I need to move it. So to move it, I say which number is smaller? 3x's. So 3x is positive, so I'm going to subtract 3x from both sides, and I get that 4 minus 3 is 1x. I didn't do anything to that 12, so it comes down. The 3x's cancel out, and then I bring down my plus 7. Now I can just go ahead and solve this equation. X plus 12 is equal to 7. Well, to solve this, identify your variable. I have to get rid of the plus 12, so I subtract 12 from both sides, and 7 minus 12 is -5. So my answer is x equals -5. Next one, -3 minus 4.7x equals 7.3x plus 9. So again, draw a line, identify your variables. They're on opposite sides of the line, so I cannot combine like terms. So I say, which one is smaller, 4.7 or 7.3? 4.7, so I add it to both sides. Bring down my -3. The 4.7s cancel out. 7.3 plus 4.7 is 12x. Bring down my plus 9. So now I go ahead and I look at this. I say, okay, I've got my variable. I can identify it. So how do I get, and I like to cover up the 12x personally, cover up the 12x, and I say, how do I get rid of that plus 9? Well, I need to subtract 9 from both sides. -3 minus 9 is -12 because the signs are the same. So 3 plus 9 is 12. Put that negative back in front. Bring down my 12x, and the 9's cancel out. So to get x by itself now, I have to divide both sides by 12. -12 divided by 12 is -1. So x equals -1. Number 3 says 2 times x plus 3 equals 6 plus 2x. So draw my line, identify my variables. I've got my variables on both sides, but I have parentheses, so I have to distribute. Okay, so that was step 3. I have to simplify. So I'm going to distribute that 2 to the x, and I get 2x. I'm going to distribute that 2 to the 3, and I get plus 6. So 2x plus 6 equals 6 plus 2x. Perfect. So now I need to move the smaller variable. Here's the thing, though. They're both equal. They're both 2x's. So it doesn't matter where you write minus 2x, okay? Because when you write minus 2x from both sides, they're going to cancel each other out. I'm going to bring down my 6. I'm going to bring down my other 6. Those other 2x's cancel out. So I get the statement 6 equals 6. Is that true? Does 6 equal 6? Yes, it does. So my answer is all real numbers. Because that's a true statement at 6 equals 6, my answer is all real numbers. So now I have 4 times x minus 2 equals 4x minus 2. Draw your line, identify your variables. Step 3 says if you have parentheses, you have to distribute. So let's distribute the 4 times x, and the 4 times -2 is -8. So I have 4x minus 8, and I have equaling, and I bring down 4x minus 2. So again, look at your x's. They're both the same value. So I just write minus 4x. It doesn't matter where you subtract from. Minus 4x minus 4x. Those 4x's cancel out. I bring down my -8. These 4x's cancel out. I bring down my -2. So here's the question. Does -8 equal -2? The answer is no. They are not the same. So therefore, they're not equal. So my answer is no solution. There is no value that we can put in for x to make that statement true ever. All right, so let's talk about the last one, getting y by itself. So that's what number 5 and 6 are like, okay? So we've been doing these types of problems, but I just want to practice this with you. So I have 3 times x plus 4 equals 4 times y minus 5. So what I'm going to do is I'm going to go ahead, I'm going to distribute. Oh, sorry. Identify the variable. Now I'm going to distribute because I have parentheses. 3 times x is 3x. 3 times 4 is 12. And that equals, well, I have to distribute on the other side as well. 4 times y is 4y. 4 times 5, or -5, is -20. So now my equation says 3x plus 12 equals 4y minus 20. I'm trying to get y all by itself. I don't care about the x. I only care about y. So cover up 4y. How do I get rid of a minus 20? Well, I have to add 20 to both sides. Bring down your 3x because you didn't do anything to it. And then I say 12 plus 20 is 32 equals, bring down your 4y, and the 20s cancel out. Next step, again, I want y by itself. So how do I get rid of that 4? How do I undo 4? Well, it's currently multiplying by 4, so I'm going to divide both sides by 4. Now, this is the part where kids get messed up. Guys, you are dividing the whole 3x plus 32 by 4. So what that means is I have to divide 3 by 4. Well, what is 3 divided by 4? Does it give me a whole number? If it doesn't, leave it as a fraction. Then I have to divide 32 by 4. Does it give me a whole number? If it does, write it. If not, leave it as a fraction. So 3 over 4 does not give me a whole number. So it is 3 over 4x. 32 divided by 4 is 8. So my final answer is 3 over 4x plus 8 equals y. You could rewrite it and switch it around to say y equals 3/4 x plus 8. I hope this was helpful. This is all the notes. So the rest of, make sure you get the rest of the assignment done. Have a great day.